thing. For a system of equations, we're looking for the point of intersection. So if there are no solutions, that means that there would be two parallel lines because those two are never going to cross. So make a little sketch on your paper if you haven't already. Now, if there's one solution, how many times do they cross each other? Just once. So I don't care how you guys draw it. Just draw two lines that will cross each other at one point. So one solution is when they cross once, and you have to write your answer as an ordered pair. So wherever they cross each other, that ordered pair is the solution to the system. Okay, so we have an example of what no solutions are. One solution would look like. If there are infinitely many solutions, that means that the two lines have to cross everywhere, which means what? How would two lines intersect each other everywhere? Well, they don't have to necessarily be vertical, but don't they just have to lie right on top of each other? Like it has to be the same line twice, right? So the way we usually draw that is go ahead and just draw any line you want to. Okay, so there's a line. And then if I were to go and graph my second line, it would end up right on top of it. So then I usually just put a second set of arrows, letting you know that there are two lines together. Now remember, the definition of a line is it goes on in both directions forever. So if these two lines cross everywhere, then we say that there are infinitely many solutions. Infinitely many solutions. That would be two of the same line. Okay? Now you guys can turn the page. All right, so graphing review. These are the different types of graphing that we've done so far. So that do now that we just completed had some of each of these. This is slope-intercept form. This is the kind that we think is probably like the easiest to graph because they have given you the slope and the y-intercept. So those tend to be the easiest ones to graph. And then standard form is the one like, what was it, number 5 on your do now, where they give you x and y on the same side. We move the x term to the other side, and then we divide by whatever number is in front of y. So that's what we did on number 5 on your do now. Okay? Yeah, it's stuff that we've. What do you mean? Switch what?
Like a 5 times a 5 over 1.
No, like, because like me and him, we do it different. So that's why.
Oh, when you have to do your slope.
Yeah.
I mean, it's just going to depend. We're not really doing that. Like, I'm going to give you the equations. You won't have to find slope. I'm going to give you the equation that you're going to start with, and then we're just going to graph them. Okay? No. And then point slope form is that one like number 6 on your do now that I was just explaining to you, where here's our slope, and then they gave you an ordered pair, but when you write your ordered pair, you have to change the sign of each of those. Like if it said minus, you made it a plus. If it had said plus, we would have made it a negative. Okay, so that was the other kind that we just did. So down here at the bottom, we're going to just review what this looks like, okay? So if I asked you guys right now to write the ordered pair that's been given, here are the two numbers. Which one is the x?
5.
It's the 5 because it's paired with the x, but since it says plus,
It's negative.
we're going to make it -5. And then the y is over here paired up with y, but you have to make it opposite, so it'd be +6.
So,
Okay, so notice, look right here. Before they graphed this, they plotted this point. So they started at the origin, went left 5, up 6. So there was their starting point. Then they said, okay, well, my slope is +2/3, which means up and right. So look at what they did. They went up 2, right 3, put a new dot. And like I've said before, when you graph on a computer, if there's a program on your computer where you graph, the minute you put 2 points on there, it automatically makes a line for you. If we're doing it by hand, obviously I'd want you guys to do 1, 2, 1, 2, 3. Like I'd have you keep going until you ran out of room, and then you'd switch directions. You go down to, see this one's a little off, down to, and then there's no more room. But either way, this is pretty accurate. So that's point slope form. That's number 6 on your do now. Questions about that graph? Okay, turn the page. Okay, so we're going to graph some. Just more graphing practice. Okay, so this one right here, this is standard. We do not graph in standard form. So copy it down here. We're going to go through that process again. Which term do I move?
5. No, X.
We need the x on the other side. So we subtract 8x. We bring down 5y equals, how would I write this side? Yeah, so -8x should go first, and then plus 20. Okay, so that was step 1, was move the x term. Step 2, what do? Divide everything by 5. Go get a cup of water. Okay. You're okay. Okay, so look, please. 8 and 5, do they have anything in common? No. I mean, they have a 1 in common, but dividing by 1 isn't going to change anything. So we're going to leave that as -8/5 x. And then what's a +20 divided by a +5? +4. There is the equation of your line in slope-intercept form. Okay? So now, where do I put my first point? On the 4, right? So we go up here to the 4, put your first point. Now my slope was -8/5. When it's negative, where do we go? Down, right. Okay, so look please. We need to start at this 4 and we need to count down 8. 1, 2, 3, 4 gets me to 0. 1, 2, 3, 4. There's a total of 8. And then go right 5. 1, 2, 3, 4, 5. Make sure that's where you guys landed. And then, is anything else going to fit? No. Go ahead and connect them with your ruler. Okay, The next one. That's point slope form, the kind we just discussed. What is my ordered pair? 2 comma negative 4. So 2 comma negative 4. That comes from here and here. Remember, you just have to make them their opposite. Okay, so you guys all know how to plot that point. You start at the origin. You go right 2, down 4. Okay, now my slope is right here. My slope is 3/4. We go upright. Up 3, right 4. 1, 2, 3, 1, 2, 3, 4. I can't do it again, but can I go down and left? Down 3, left 4. Okay, are we ready? Everybody have those done? Okay, scoot it up. We just did 2 like this on your do now. Y equals a constant. You put your first number on the y-axis, and where does it go? Across. Horizontal. Okay, now this one, we plot on the X, and it goes straight up and down. It's your vertical. Oh, follow the grid line. You guys just use your ruler to follow that grid line, please. Okay, flip it. Well, not flip it, but turn the page. We're just doing lots of practice with graphing. Okay, so please look at this one. This does not say y equals negative 2. So it's not a horizontal line, okay? It says negative 2x. So if there's an x attached, this is our slope, right? Right? Okay. If there is not a number right here, we don't know where our starting point is. Well, can't we just put a 0 there? If there's not a number, we could have like plus 0, and 0 is our starting point. And with a slope of negative 2, negative 2 over 1, where do we go? Upright or downright? Down, right. So down 2, right 1, down 2, right 1, switch. Look up here. Start back here, go up 2, left 1, up 2, left 1.
I did that wrong.
You told Melissa that she did it wrong.
Shh. All right, down here at the bottom. What is my starting point? -4 on the y-axis. And then our slope is -2/1 again. So where does that mean? Or where does that go? Down right, good. So can I go down 2?
No.
Okay, so if I can't go down right, I'm going up left. So up 2, left 1, and you guys do that as many times as you can. Looks like you can have a total of 5 points altogether. And then when you're ready, turn the page. Yeah. Okay, so they're just kind of giving you a definition here of like what a system is in general. It's basically just a combination of things or parts forming a complex or unitary whole. So there are all kinds of systems that we're used to seeing, like a railroad system, sewer system. So it's basically telling you just think of a system as meaning more than one thing working together. Okay, so when I talk about a system of equations, I am talking about two equations that we're going to put together somehow. We're going to figure out where these two intersect each other. Then solution of a system is any point that lies on each line in the system. It's the crossing point or the intersection. Okay, so that's what I was showing you on the front. I drew those little sketches showing you that if two lines do intersect, they will have one solution, and we'll write the ordered pair of where they cross. Okay? Types of solutions, we've already talked about this. We can have one solution. I will tell you that's the kind that's going to happen most often, because especially if I have you graph two lines, I'm going to want you guys graphing two lines that do end up crossing so you can write down the ordered pair. But every once in a while, they will be parallel. And if the two lines are parallel, there are no solutions because they don't cross at all. And then the system of equations that has an infinite number of solutions, that means that they are the same line. So like the same line was given to you twice. Okay, go ahead and turn the page. There it is. There's the picture I had you guys draw on the front. No solutions, parallel lines. One solution, they will cross at one point, and we will write the ordered pair of where they cross. Now this symbol, that's the infinity symbol, you guys. That's the infinity symbol. So if there's an infinite number of solutions, you have one line and then you graph the exact same line and it falls right on top of it. Okay, so down here they're just going to ask you, how many solutions does this system have? Write that down. No solutions. Okay, turn the page. this one? This would be the infinite number of solutions. I like to say infinitely many. Or you can say there's an infinite number of solutions. And then down at the bottom, how many solutions? One solution. And because we can see where they cross, we are actually going to write the ordered pair of where they cross. What is it? 2, negative 2. You have to remember, we have been doing slope so much that with slope, you guys are always thinking up, down first, then left, right. But when we're writing ordered pairs, it's left, right first. So we went to the positive 2, and then it's up, down after. So it's right 2, down 2, so it's 2, negative 2. Is everything okay so far?
Yeah.
Okay, turn it over. They want us to identify the solution. So they're asking you for the ordered pair of where they cross. Good job. 3, negative 2. The next one, negative 2, 1. Negative 2, 1. And please make sure you guys are writing your ordered pairs in parentheses. That's how they are supposed to be written. And then once you've done that, go ahead and turn the page. The fun stuff is coming. Where do they cross? 4, 4. No. Positive 4, positive 4. When you go to the right, it's positive. When you go up, it's positive. Okay, so now everything that we just did was pretty simple because they gave you the picture. All you guys had to do was tell me where it crossed. Well, most of the time you're not going to be given the picture. Most of the time they're going to give you the 2 equations. You are going to have to graph both of them on the same coordinate plane and then look to see where they cross. Okay? So this one I'm going to do in pink, and then I'll do the other one in a different color just so you guys can see the difference. But you guys are just doing one line at a time. Where do I start? The 2. Okay. Now if it's positive 1/2, we go up, right. Up 1, right 2. Up 1, right 2. I know it's kind of hard to see. I actually don't even think that one was on there. That one's not even part of the graph. There, you should have been able to go up 1, right 2, up 1, right 2, done. And then you can go backwards. You can go back to your starting point and go down 1, left 2, down 1, left 2. Now, don't even think about looking at that second equation until you have plotted the first one and connected them. So make sure you get those connected, please. This is why it was so important during the graphing lessons that we've already done that you guys were able to actually do graphing, because here you are graphing again. All right, this one, starting point. Where do I start? Negative 3. And then my slope is positive 3 over 1, so where do I go? Up 3, right 1. Up 3, right 1. And you should see that it just intersected a point, correct? Okay, so the method we are using right now to solve a system is graphing. Once you guys graph it, you're not done. If you see where they cross, you have to tell me the ordered pair. So where are they crossing? 2, 3. Now, don't turn the page yet. Don't turn the page. Okay? If I just told you the ordered pair 2, 3 is the solution, watch. I need you guys watching this. Watch what happens when I plug in a 2 and a 3 for x and y. Just watch. If my y is supposed to be 3, I'd put it there, equals, and then 1/2 times x, which was 2, plus 2. I want you guys to see what happens. What's half of 2? Half of 2 is 1. And what's 1 plus 2? 3. So if this is a solution to the system, what that means is if I plug those two numbers in for x and y, my left side and my right side will truly be equal to each other. And they were, right? If I had plugged those two numbers in and this side did not equal 3, it wouldn't be a solution. Okay, now watch what happens when I plug it into the other one. Do you think the other one should be true also? Yes, if it's a solution to the whole system, when I plug it into both, they should both be true. So I would write the y, which is 3, equals 3 times x, which was 2, minus 3. Well, what's 3 times 2? 6 minus 3. So 3 does equal 3, right? So both of those end up being true statements. So I just wanted you guys to understand why this truly is the solution to the whole system. And it's because if I were to take this x and this y and plug them into both equations, I would get 2 true statements. What do you think if I got 1 true, 1 false? Is it a solution to the whole system? No. What if I got 2 falses? Then clearly not. The only way it's a solution to the system is if you get 2 trues when you plug it back in. Okay, now you can turn the page. Okay. We've got 2 more right here that are in slope-intercept form. Starting point, -2. Now my slope is 5/4. Where do we go? Upright. So you're going to count up 5, right 4, and that's the only other point we can fit. So go ahead and connect those two. Okay, then the bottom one, the starting point, is -1. And doesn't it have the same slope as the other line? It's the exact same slope. Well, if 2 lines have the same slope, what are they? Parallel to each other. So when I go ahead and I go up 5, right 4, 1, 2, 3, 4, 5, 1, 2, 3, oops, I went too far. 1, 2, 3, 4. I think I could also, no, I can't go down 5. You can only go down 4. So now if you connect those two, you should end up with 2 parallel lines. So if that were the picture that you guys got, what would you say is the solution to that system? You would have to say that there are no solutions. You don't say parallel. Okay, I'm not asking you what kind of lines they are. I'm asking you what's the solution. So if they don't cross, you just say, hey, there's no solutions. Is that okay? All right, focus question number 6. This one's going to take some work because it's standard form. We cannot graph them in standard form. So I'm going to take this guy. We're going to go over here and work it out. Good news is this one's actually only going to require 1 step instead of 2. What's the term that I move? The 2x. Okay, go ahead and subtract 2x from both sides. So you bring down the y, bring down the equals. We can't combine those. How would I write it? Negative 2x plus 1. Why don't I have to do the division step like we usually do? There's not a number in front of y. So I don't have to divide by anything. That one's just done. Let's plot it. Start at the 1. And if my slope is negative 2, I'd stick a 1 underneath it, right? And where would we go? Down, right. So I want to go down 2, right 1, down 2, right 1, down 2, right 1. And there's room to go up to left, up to left. Yeah, it's a good time in here. Okay, look guys, make sure, put that ruler down, get all those points connected. And now our first line is done. Okay, so now we're gonna have to take this second equation and I'm gonna actually work this one out right here. Yeah, that's what I'm doing. So anytime I move terms from one side to the other, I like there to be a 1 in front. Okay, so what term do I move? So subtract 1x. Is that what you meant?
I do it that way.
Okay, now this 1y is actually a negative 1y. And then this side, we cannot combine them. So when you write it sideways, start with the x term and then the minus 4. Now, if this were a positive 1, you would not have to divide because dividing by positive 1 never changes anything. But if it's negative 1, we have to do the division step because that will change. Dividing by negative 1 just changes the signs. So instead of a negative 1x, it becomes positive 1x. And instead of negative 4, it becomes positive 4. Yes. Okay, so the starting point is now up at the 4. Let's get this down a little bit so you guys can see. Okay, now, positive 1 slope means up 1, right 1, up 1, right 1. Well, I can only do that once, up 1, right 1. But then, bless you, but instead of going up and right, we can go down, left, down, left, down, left, down, left, down, left. Put your ruler or whatever straight edge you're using, connect them. Now again, we're not done because once you have them graphed, you have to tell me what the solution is. So here's their point of intersection. What is the ordered pair? Negative 1, 3, is that what you said? Good job. Negative 1, 3 is where they intersect each other. Okay. Once you have that one done, go ahead and turn the page. This is the last one we're going to be graphing together. Are you ready? Let's start with the bottom one. The bottom one is already in slope-intercept form. That one's the easier one. Okay, so starting point, negative 3. And then our slope is 1/2. Where do we go? Up 1, right 2. So I'm going to go up 1, right 2. Now this graph is quite a bit larger, so you guys can fit lots of points on there. You keep going up and right until you run out of room, and then go back to your starting point and go down 1, left 2 as many times as you can. You get lots of points. And then connect them. Does everybody have that first line? This one? Okay, so then when we go to do the other one, watch. This top one is point slope form. So we need to identify the ordered pair from here, and we need the slope. Okay, so what's my ordered pair? Negative 1, comma, 4? Negative 1, comma, 4. So it's that one becomes the opposite. That one becomes the opposite. Okay, that's your starting point. My slope is, yeah, and I'd stick a 1 underneath it. So plot negative 1, comma, 4. So you're going to start at the origin. You're going to go left 1, up 4. That is your starting point. Now if our slope is negative 2, it's down 2, right 1. So starting at my first point, down 2, right 1. You should get it to cross at one of the points that are already plotted. And then connect all those points. Do they cross? So since they cross, where do they cross at? 2, comma, negative 2. Okay, down at the bottom, the 3 different options here. Okay, so let's write down, if you graph them and they're 2 parallel lines, how many solutions are there? No solutions. If the lines do cross, there's 1 solution. And if you have 2 of the same line, yeah, I'm just going to draw the symbol because I'm just being lazy right now. Infinitely many solutions. All right. When you're done with that, turn it over to the last page. Okay, so this just gives you the steps. If you guys were to have to go through and do this on your own, then, here are the steps. Step 1, you just graph each line, including as many points as possible. That's what we just did. Decide if it has 1, 0, or infinitely many solutions. And then if it has one solution, you have to write the ordered pair of where they cross. Otherwise, you just write either no solution or infinitely many. Okay? So because of the time, it's 11:47. Class has to end at 11:50 today. We're going to stop there. We got all of the notes done. So first thing tomorrow when you guys come in, we're going to be practicing some more of these. Keep these notes. Do not lose them.